Sir, is it C?
So what is your wavelength? How much did you get?
I got 0.3.
Good, that is correct. And then multiply the wavelength with the given frequency. So yes, 150
Okay, sir.
meters per second. Okay, Anushka and Christine, what about you?
Yeah, sir, I got C as well.
Sir,
Okay,
I
good.
got it. I didn't recall the formula before, but yeah, I got it now.
So either remember the formula or at least remember the derivation. Derivation is not that difficult. So it's better if you can remember any of these formulas directly. All right, so Ahan, you have the last question now. Can you read out the question, Ahan? So this
A
is theoretical.
fixed, a fixed mass of an ideal gas expands slowly at constant temperature in a container. Three statements about the gas molecules during the expansion are: they collide with the walls of the container at a reduced rate, they travel further on average between collision, their average kinetic energy decreases as the gas expands. Which
But
statements are
tell
correct?
me your approach, Ahan. Where did you get stuck here?
Well, I got the right answer, but the
Mhm.
thing is, so why would one be correct? Is my question.
So first tell me how is second correct and third wrong?
Uh, Third will be
Oh
wrong
wait,
because
so you have
temperature.
seen the wait. So you have seen the answer. Is A the answer?
Yeah, I think so.
Okay, wait. First, let me cross check. Ah, yes, it is A. So explain.
So average kinetic energy can't decrease because temperature is constant, which is the sum of average kinetic energy of molecules. So that discards our third option.
Wait. So what will happen to kinetic energy? Will it increase or stay constant?
Stay constant.
Yes, temperature is constant, so kinetic energy should be constant. So three is definitely out. Oh, which means only A is left.
Yeah, which is why I got A. But why
Okay.
would they collide at a reduced rate?
Ah, that's a tricky one. So Anishka and Christine, both of you try to think of a logic for one. Collision.
Sir, I thought that if it expands, doesn't that mean the volume would increase?
See, the volume of a gas is equal to the volume of the container.
Yeah,
Container is not expanding.
okay. But like,
Mhm.
okay.
Container is fixed. That is not moving. This one is actually
Sir,
tricky.
because the gas is expanding,
Mm-hmm.
does it travel? I mean, does it need to travel a larger amount of distance to reach the container walls? In that case,
So partially you are correct. But let's focus on the main formula. See, remember the basic Newton second law, F is equal to ma. That is also written as change in the momentum upon time, right? So in the current question, if the temperature is constant and the gas is expanding, what is going to happen to the force? Just using some common sense logic. If the gas is expanding, will force increase, decrease, or constant? Force acting on the wall of the container. Okay, Ahan, what about you? The force acting on the walls.
Why would it change? Is my question.
Okay, so why will it not change? Is my question.
So, okay, so average kinetic energy remains the same, right? Because temperature is constant. And
Hmm.
also, wasn't kinetic energy related to momentum by p square upon 2m or something like that?
Could you repeat which formula?
P square upon 2m, I'm not sure. Was that for kinetic energy?
That is kinetic energy.
Right. So, if kinetic energy is the same, momentum shouldn't be increasing.
This particular formula, okay, see, you can use for a single gas molecule. There are hundreds and hundreds of gas molecules going in a random direction. So this may not work.
Okay, but
See,
sir,
how can you incorporate the rate of collision in any formula? That will give you the answer.
but also logically speaking, if a gas is expanding,
Hmm.
wouldn't more molecules hit the walls of the container?
Okay, for this, I'll have to show you the animation. It's difficult to explain in theory. But see, let's do one thing. As of now, let me give you the theoretical solution. Later on, I'll figure out the animation for this. Actually, the rate reduces. So let's understand the theoretical version first. Change in momentum. So, Ahan, what's the formula for change in momentum?
MV final minus MB initial.
Divided by time. Now, let us assume initial velocity is zero just for the sake of it, for simplicity. All right, so Ahan, this is the force on the wall due to one gas molecule. Let's say if there are n gas molecules, what will be the total force?
N times MVF by T.
And it is the n by t, which is your rate of collision. So right till this point and then think. In fact, yes, this is quite tricky. So, Ahan, is this from this year? This particular question,
I don't know. I just
2023.
Yeah, sir, this is 2023. I solved this too.
Oh, you solved this
Yeah, I also
to
used the process of elimination.
get the answer. Fine, let's do one thing. Let me figure out a much simpler way to answer this. This is going a bit convoluted. So let it be. Ahan, I'll
So,
send you the solution. Yes, Christine.
so I solved this as well, and when I didn't understand the first part, I checked on Revision Village, and they
Oh,
said
what they
something
have done.
about yeah, they said something about as a something related to distance that the particles have to travel. That's why I said that before, but I don't know if
Wait,
it's correct
okay,
or
so
not.
wait. So I'll go through that solution in the meantime. So can you send me the question code? I mean, code
Yes,
as
sir.
in,
It's
I mean,
2023.
mhm.
May. So it's I think you go to 12, and it's the ninth question.
Hang on, let me go there. I'll check. In the meantime, all of you solve the next question. 1 second. Okay, so in the meantime, try solving this question, electromagnetic induction. And yes, Christine, could you repeat 2023?
May session. So you go to 12, and I think it's the ninth question.
Okay.